Hello Senior 2. Today I'll talk about wave motion. Waves can be classified into mechanical wave and electromagnetic wave. Mechanical wave require a medium to transfer the energy. Electromagnetic wave don't require a medium to transfer the energy or the motion. First, I'll talk about mechanical wave. Mechanical wave have two types, transverse wave and longitudinal wave. Longitudinal waves, for example, sound wave. Transverse waves, for example, water wave. First, mechanical waves. Mechanical waves to produce a mechanical wave, we need a vibrating source. For example, a stone when we through the stone in the water. The disturbance happened through the medium. The medium is called the water, so it's called liquid medium. So mechanical wave needs a materialistic medium to transfer or needs a medium to transfer. For example, water and sound. Conditions of mechanical waves. First one, source of vibrating. Source like the stone. Number two, disturbance that transfers from the source to the medium. Number three, the medium to transmit the disturbance like the water. It's called liquid medium. Now, types of mechanical waves. We have two types of mechanical waves. First, transverse waves, and number two, longitudinal waves. To describe the nature of transverse waves, we carry out the following experiment. First one, bring a long rope and fix it into a vertical wall. Number two, hold the other end of the rope with your hand. Number three, move the end of the rope with your hand up and down. Observation. A wave is generated through the rope. Continue in moving the end of the rope up and down. The end of the rope moves up and down in a simple harmonic motion that transfers along the rope as continuous waves, and it's called transverse wave, which are called traveling waves. We found that the direction of wave propagation is perpendicular to the molecules of the medium, and the maximum displacement of the molecules of the medium in the positive direction is called crest, and the minimum displacement for the molecules of the medium in the negative is called trough, and the wavelength of the transverse waves is the distance between two successive crests or two successive troughs. For example, waves on water surface, propagating waves in strings or loops. Number two, longitudinal waves. Steps. First one, put a loop on a smooth horizontal plane and attach the loop between two springs. One of them is longer than the other, and each of them is attached to a wall. Okay? Number two, put the loop a distance x to the right side, then leave it to return to the equilibrium position. The observation, the spring compresses in the right side, and the compression transfers through the spring. Put the root number 3. Put the root at distance x to the left side, then leave it to return to the equilibrium position. The springs refines or refraction in the right side, and the refraction transfers through the springs. We found that the direction of vibrating of the medium is the same line of the wave propagation, and we found that we have the region where the molecules of the medium become close to each other, and it's called compression, and the region where the molecules of the medium become far from each other is called rarefaction. And the wavelength of the longitudinal waves, the distance between two centers of two compression or the center of two rarefactions. And the examples of longitudinal sound wave or wave. The wavelength can be determined from the relation lambda equal total distance over number of waves, and frequency, number of waves per time, and periodic time, time that taken to make one complete solution. So T capital equals T over M. Reduction of speed of propagation of waves. The relation between wavelength and frequency and the speed of propagation. As we know from Mendel, velocity equals displacement over time. When we make a wave, so displacement equal lambda, so V equal lambda over T. When we make an one complete solution, so we have the periodic time, so V equal lambda over T, T capital, periodic time, and the reciprocal of the periodic time equal nu, so V equal lambda T nu. V speed of light, frequency nu, and wavelength lambda, and its measuring unit meter, frequency hertz, speed of light meter per second.